Hello, and welcome to What Do Geoscientists Do, or what is the role of geoscience, kind of along those lines. This is a kind of 5-10 minutes just to talk through the different potential careers of a geoscientist. So, and when I've thought through the geoscientist role here, I've looked at kind of physical geography, geology, geoscience, that kind of aspects of the physical side of geography. So this is just a poster that was developed by the Geological Society of London, and it generally just shows you all of the different things that geoscience is used for. And you can get the PDF, the link is at the bottom there, and will give you a much clearer kind of image, I think. But it shows you all the different things in which geoscience is used. So we can see you've got planetary geology, GIS and remote sensing, renewable energy, nuclear, erosion management, oceanography, hydrocarbons, energy storage, contaminated groundwater. The list is genuinely endless. So I've just kind of cherry picked a few of the different kind of major ones, and I'm just kind of going to talk through what that role is, what that person would do in that role, and then you've got links to each of the careers as well. So there's career profiles on various websites that I've linked to. So I'm going to start with the hydrogeologist. A hydrogeologist generally is looking to help preserve water, or where our water is coming from for us to drink, for us to wash, for us to do anything that we want to do. Yeah, so water contamination, resources, basically what is understanding what is underneath our feet. And then there's the job role there. In terms of the images on the screen, so every drop counts, reduce your use, really starting to think through that. Various schemes in the UK and some other kind of European Western countries obviously charge for water, but they also charge for excess use of waters. We've got the nice image at the top there is just showing you aquifers, and it's like understanding that aquifer and understanding the recharge of that aquifer and how much water we can take out of that aquifer and what's actually sustainable for an area to use. The bottom image is actually a borehole. So the borehole's in the middle, the kind of the things around it to stop people going in. And boreholes are obviously used for a whole bunch of reasons, but water depth, to collect water samples, to check contamination rates, or to check what's actually in the water to make sure it's drinkable, to make sure it's usable. The mining geologist, I've just listed some things that we mine, so salt, lithium, gravel, gold, copper, gemstones. There's a whole bunch of stuff that we mine. So I don't know if you've heard of the quote, which is, if it's not grown, it's mined. And that is very true. And then there's just some kind of pictures that show you. So we've got some copper pipes, obviously for plumbing works. It's the first thing that pops ahead. We've got some mobile phones. Everybody has a mobile phone. Everybody's got a laptop. Everybody's got some sort of tablet or something in order to watch TV or just to contact people. But they all contain minerals, and those minerals have come from our Earth. In terms of planetary geology, in order to undertake any of that, we need all of the satellites. For remote sensing, we need those satellites. Again, all of that material has come from our Earth. So the mining geologist is all about kind of finding that material. So collecting and finding that material, analysing the risk of that mining remediation. So areas where we've been and we've collected that material and then putting that back into something that looks nice for people to walk past and see. In terms of a researcher, so a researcher is somebody that basically does research. It sounds really old, I know, but it depends what you want to know about. Do you want to know about climate? Do you want to know about tectonics? Do you want to know about prediction? Do you want to know where material is? Do you want to learn about risks? So risk prediction, so maybe earthquake prediction or landslide prediction. So it's all about trying to understand more, and how do we gain that understanding. So in terms of a researcher, potentially field work, potentially lab work, or computer modeling of some descriptions. So in ways of basically trying to find stuff out and then showing that and making that material, what you found out, accessible to not only to other researchers, but also communicate that to the wider population. In terms of an environmental consultant, they are very much used for making sure that what is being done is done in a sustainable and environmentally friendly way. So a lot of industries now actually employ environmental consultants. So the mining and hydrocarbon industries are employing environmental consultants in order to make sure that what they're doing is as sustainable as it possibly can be, is as environmentally friendly as it possibly can be. So as an environmental consultant, there's a lot of field work that involved. There's also a lot of desk-based work involved where you're combining multiple data sets together. You will develop models, you'll advise on mining or on building new houses. And there's a variety of profiles there. So there's two different profiles from two different areas of environmental consultancy. A spatial analyst is basically using GIS or remote sensing data in order to really investigate an area, to kind of show and develop understanding of that area. You mostly work with clients, and it's used in many, many industries, from town planning to areas of like understanding volcanoes and volcanic risk. So it's a wide spectrum of spatial analysis that can happen. And there's again multiple profiles at the bottom there. Exploration geologists. When we say exploration, you naturally think oil and gas, but also mining. And they do exactly what it says on kind of on the tin. Really, they explore. They go and they try and find oil or gas or relevant minerals that we need to use in order to sustain our lives as they are and society as it is. And it's about determining what's under the subsurface or what's around us or how we can kind of use that stuff in order to help us. So there's a lot of data interpretation and generation of 3D models in order to try and understand what's actually underneath the surface so that we can work out if it's actually economically viable to get that oil or gas, or economically viable to go get that gold or that lithium. Again, there's more profiles at the bottom there. A volcanologist, so you can monitor volcanoes, you can do academic research, field work, lab work, PC, like computer modelling. It's also done via remote sensing and lots of satellite data that you can get as well. This image at the top here is just a really nice example of the satellite data that can be collected, and then you can kind of implement that through computer modelling, and it really helps you kind of start to understand how a volcano might explode and therefore kind of start to determine that risk. The photo in the background is Mount Teide in Tenerife. And then you've got the geophysicist or the kind of seismologist. It's very similar in what they could potentially be doing. So oil and gas or mining, so in terms of like understanding what's underground. So you've got this image here, which is the seismic section at the bottom, and you can see all the lines, and those lines are different sedimentary layers. And what we can start to see within the sedimentary layers, you can start to pick out where that oil might be, or where that gas might be, or where that really key horizon is for that coal or gold or lithium or whatever it is you're looking for. Just to explain the words on this seismic section, you've got hanging wall and footwall, which relate to the fault movement. You can see here it says growth faults. This is a normal fault. And then what you've got, hanging wall is always above your fault plane, and the footwall is always below the fault plane, just to kind of put those into context. They will generate three-dimensional models based off their data that they collect. And then you can see I've got seismic hazards there. So I've just given you an example of earthquakes, but I mean earthquakes when they occur, or fault movement. So you think of like around the Himalayas where you get lots of earthquakes, or along the San Andreas Fault where we get quite a lot of earthquakes because of that fault movement. So you can start to predict those seismic hazards and start to understand those seismic hazards. And again, there's a couple of profiles down here for you to go and check out. Okay, thank you.